Good morning, class. Welcome. Today, we're going to bridge a really important gap, the one between the math you've learned in algebra and the real-world strategy you'll need in the boardroom. We're diving deep into quadratic functions. Now, I know you've seen these curves before, but we're going to look at them as more than just abstract equations. We're going to see them for what they really are: powerful, predictive tools for making some of the most critical decisions a business faces. We're moving past simple straight lines to understand the nuances of curves that model the rise and fall of profit, help us pinpoint the lowest possible costs, and ultimately find the absolute peak of a company's financial performance. So you see this, and you're probably thinking, a roller coaster? What does that have to do with a business lecture? And that's a fair question. The answer, though, is actually pretty profound. Think about the arc of a roller coaster, that climb, the peak, and the descent. It's a perfect real-world parabola. And it turns out that exact same mathematical shape, governed by the very same principles, is what we use to model the dynamic forces inside a business. It maps the rise and fall of revenue, the behavior of costs as production scales up, and most importantly for us, it helps us find that one precise point of maximum profit. So today, our goal isn't just to understand this curve, it's to master it as a strategic business tool. All right, here's our game plan for today. We're going to start with the why. Why are these curves so incredibly important in a business setting? Then we'll get into the mechanics, the anatomy of these functions, to really understand what makes them tick. From there, we'll learn how to solve for critical thresholds, things like your break-even points. And then we get to the heart of it all, finding that sweet spot for maximizing profit and minimizing cost. We'll bring it all together with a real-world case study, and then we'll wrap up with some crucial advice on how to avoid common mistakes as you start applying these tools in your own work. Okay, let's jump right in. At its core, the business world is really just a massive landscape of optimization problems. I mean, think about it. A marketing director needs to figure out the perfect amount to spend on an ad campaign to get the most new customers. A factory manager has to find the ideal production volume to get the lowest possible cost for each item. And a CEO, they need to find that perfect price for a product to bring in the absolute maximum revenue. These aren't just hunches. You can't guess your way to the right answer. The parabola gives us a powerful visual framework to answer these questions with precision, turning what might feel like intuition into a concrete, data-driven strategy. Now, to use this tool effectively, we have to be fluent in its language. We need to really understand what each piece of a quadratic function does and what it represents in a business scenario. So let's break down the fundamental building blocks of these curves. Think of this part as learning the grammar of optimization. Once we know the language, we can start telling some pretty powerful stories. So here it is, the formal definition. A quadratic function is a second-degree polynomial. And that term, second degree, is absolutely key. It's referring to that x raised to the power of 2. That x squared term, well, that's the engine of the whole thing. It's what takes a boring straight line and bends it into that powerful parabolic curve we're so interested in. The A, B, and C are our control knobs. They fine-tune the shape and position of our curve. We're going to talk a lot more about A in a second, but B often influences the slope, and C is typically our starting point, our y-intercept. In business, that's often a fixed cost, like rent. And of course, A cannot be 0. Why? Because if A was 0, that x squared term vanishes, and we're just left with a straight line, which can't model the peaks and valleys that are so crucial to our analysis. And the graph of that function is the parabola. But I really want you to think beyond just a simple U-shape. For us as business students, a parabola is a story. It's a narrative. Let's imagine it. The horizontal x-axis is the price of a cup of coffee. The vertical y-axis is your daily profit. If you set the price too low, you lose money. As you raise the price, your profit starts to climb, the curve goes up. At some point, you hit that perfect price, the sweet spot that gives you the maximum possible profit. That's the very top of the parabola. But what happens if you keep raising the price? Well, fewer people will buy your coffee, and your profit starts to fall again. The curve comes back down. See? It's the whole story of profit optimization told in one elegant arc. Now, let's focus on what is arguably the single most important part of our function, the coefficient A. Just by looking at the sign of A, you immediately know what kind of problem you're dealing with. If A is positive, the parabola opens upwards, kind of like a bowl. This shape has a single bottom point, a minimum. This is the perfect model for analyzing costs. As a manager, your entire goal is to find the production level that gets you to the very bottom of that bowl, because that's your lowest possible cost. On the flip side, if A is negative, the parabola opens downwards, like a hill. This shape has a single peak, a maximum point. This is the model you'll use for revenue and for profit. Here, your objective is to find that one input, that one price, that gets you to the very top of that hill, because that's your highest possible return. So checking the sign of A is always your first step. Okay, knowing the general shape of the curve is a fantastic start. But for real strategy, we need specifics. We have to identify critical points along that curve. And the most fundamental of these are the x-intercepts, the spots where our parabola crosses the horizontal axis. In business language, this isn't just a math concept. This is your break-even point. It's where your total revenue exactly equals your total costs and your profit is precisely zero. Finding your break-even points is absolutely essential for managing risk and defining your zone of profitability. So, how do we find these break-even points, or as they're also known, the roots or zeros of the equation? Well, we have a toolkit with three main algebraic methods. First up is factoring. When it works, it's quick, it's clean, it's elegant. But, and this is a big but, it only works for relatively simple equations where the factors are pretty obvious. The second method is completing the square. Now, this is a much more robust method. It can solve any quadratic equation you throw at it. It's also really useful for changing the equation into a different form that helps us find the vertex. But the process itself can be a little messy, and it's easy to make a small error. And that brings us to the third and most powerful tool in our arsenal. And that, of course, is the quadratic formula. Let's say together x equals negative b plus or minus the square root of b squared minus 4ac, all of that divided by 2a. I cannot stress this enough. Commit this formula to memory. It is your universal key. It doesn't matter how complex or ugly the numbers in your profit function are, this formula will always, without fail, give you the solution. For any serious business analyst, this is your most reliable and robust tool for finding those critical break-even points. Now let's zoom in on one piece of that formula, the part under the square root sign, b squared minus 4ac. This is called the discriminant, and it's more than just a piece of a formula. It's a powerful diagnostic tool. It tells a whole story. If the discriminant is a positive number, you're going to get two distinct, real solutions. In business terms, this is great news. It means you have two break-even points and a profitable operating range between them. If the discriminant is exactly zero, you get only one solution. This means your profit peak, the vertex, is sitting right on the x-axis. You have one single price where you break even, and every other price results in a loss. And what if the discriminant is negative? Well, you can't take the square root of a negative number, so there are no real solutions. Your profit parabola never even touches the x-axis. This might sound like bad news, but it's an incredibly valuable discovery. It tells you that with your current business model, it's literally impossible to make a profit, and you need to fundamentally change your strategy. Okay, so we figured out how to find the points where profit is zero. That's a huge part of risk analysis. But now we get to shift our focus to the most exciting and strategically important point on the entire curve, the apex. Whether our goal is to drive costs down to the absolute minimum or to push profits up to the absolute maximum, we are ultimately looking for this one single optimal point. And in mathematics, we call that the vertex. This right here, this is the question that should keep every manager and every CEO up at night. It's not enough to just be in the block. It's not enough to be profitable. The goal is to be maximally profitable. So where is it? Where is that elusive sweet spot? What is that one single price or that one production level that takes our business to the very top of the profit mountain or to the very bottom of the cost valley? The answer to this critical question is found at the vertex of our parabola. And lucky for us, we have a beautifully simple and direct formula to find it. The x-coordinate of the vertex is simply x equals negative b divided by 2a. This formula works because the vertex always lies on the axis of symmetry, which is exactly halfway between the two roots we found earlier. This simple calculation gives us the precise input, be it price, quantity, ad spend, whatever, that will produce the optimal result. And once we have that magic x value, we just plug it back into our original quadratic function to find the corresponding y value, which will be our maximum possible profit or our minimum possible cost. All right, we've covered a lot of theory, but theory is only useful if we can apply it. So let's step out of the classroom for a minute and into the manager's office. We're going to take all these analytical tools and apply them to a practical, real-world scenario. Let's see firsthand how these formulas can drive a critical business decision. Okay, class, put on your manager hats. We're running a new coffee shop, and our analysts have given us this function to model our daily profit, px, based on the price x we set for a latte. The function is p of x equals negative 10x squared plus 80x minus 120. Now, the very first thing I do as a manager looking at this model is identify my coefficients. So a is negative 10, b is 80, and c is negative 120. And my eye goes directly to a. Since a is negative, I know instantly this is a downward opening parabola. That's great. It confirms that there is a maximum profit to be found, which is exactly what we're looking for. The model makes sense. Now, as the manager, my first concern is always managing risk. I need to know my boundaries. What's my window of profitability? If we set the price too low, we won't cover our costs. If we set it too high, customers will walk away. So my very first analytical task is to figure out our break-even points. And to do that, I need to solve this equation for the exact moment when our profit, P of x, is equal to 0. Okay, let's do the math. We take our profit function and set it equal to 0. So negative 10x squared plus 80x minus 120 equals 0. Now to make life easier, we can divide the whole thing by negative 10. That gives us a much cleaner equation. X squared minus 8x plus 12 equals 0. This looks like something we can factor. We need two numbers that multiply to positive 12 and add up to negative 8. That's got to be negative 2 and negative 6. So we can factor this into x minus 2 times x minus 6 equals 0, and that gives us two solutions, x equals 2 and x equals 6. Now, what does this mean for our coffee shop? It gives us our golden rule. We will make a profit as long as we price our lattes somewhere between $2 and $6. Anything outside that range, and we're losing money. All right, now for the big question. Knowing our profitable range is great for not losing money, but our goal is to make the most money possible. We want to find the very peak of our profit curve. So the next question is obvious. What is the single best price we can charge to get the absolute maximum daily profit from our lattes? To find that answer, we use our vertex formula. X equals negative b divided by 2a. We know from our function that b is 80 and a is negative 10, so let's plug those in. We get x equals negative 80 divided by 2 times negative 10. That simplifies to negative 80 divided by negative 20, and that gives us an answer of 4. The math is crystal clear. The single best price to charge for our latte, the price that will maximize our profit, is exactly $4. So this is the final piece of the puzzle. We know the optimal price is $4, but what's the actual profit we'll make? What's the best we can do? To find out, we take that optimal price of x equals 4 and we plug it back into our original profit function. So P of 4 equals negative 10 times 4 squared plus 80 times 4 minus 120. Let's work it out. That's negative 10 times 16, which is negative 160, plus 320 minus 120. And when you add all that up, you get a profit of $40. And there it is. That's the y-coordinate of our vertex. That is the peak of our profit parabola. Our analysis tells us, with certainty, that by pricing our lattes at exactly $4, we can achieve a maximum daily profit of $40. We've just seen how powerful these tools can be when applied correctly. So to wrap up our lecture today, I want to leave you with some really important practical advice. Using this kind of math in a real business setting requires absolute precision. A tiny calculation error can lead to a massively flawed strategy, and that can have very real financial consequences. So it's absolutely critical that you develop meticulous, disciplined work habits right now. Let's go over a few key points for your intellectual toolkit. First, and I can't say this enough, double-check your signs. A misplaced negative sign in the vertex formula is probably the most common mistake I see, and it will send your answer in the completely wrong direction. Second, always be clear on your variables. X is your input, the thing you control, like price. Y is your output, the result, like profit. Don't mix them up. Third, always think about the context. If your math tells you that the optimal strategy is to produce negative 50 chairs, you know something has gone wrong. You can't make a negative number of things. And finally, and this is maybe the most important rule of all, always apply a sanity check. Does your answer make sense in the real world? If your model says the best price for a latte is $500, you need to step back and question your assumptions or your math. Your final answer must be logical and defensible in the real world. And we'll end with this thought. Over the last hour, we've gone from abstract theory all the way to concrete business strategy. You now have a fundamental toolkit for optimization. But this knowledge isn't just about passing this class. It's about developing a new way of thinking, an ability to look at a world of infinite choices and find the single best path forward. So I'll leave you with this question to ponder as you continue in your careers. Now that you have the tools to find the optimal solution, what will you choose to optimize first? Will it be pricing, production, marketing? The applications are truly endless. That's all for today. Thank you.